Welcome to PET605 Example 1 Collapse Pressure Test. Shown in the picture are well tubular recovered from a North Sea well. To the left is a 9 5/8 inch 53.5 pounds per foot N80 casing, which evidently is not collapsed. To the right is a 47-pound N80 joint of the same diameter that was installed by mistake and later failed because of high external pressure. Also shown to the right is the collapsed production tubing that was deformed by the collapsed casing. The nominal wall thickness of a 47-pound casing is 1.2 centimeters. The nominal wall thickness for a 53.5-pound casing is 1.4 centimeters. The diameter to thickness ratios are 20.4 and 17.7, which means that both N80 tubular are described by the API plastic collapse equations. This is the reference paper for the example problem. Material from the paper is mandatory in PET605 well intervention. The SPE paper will be posted on Canvas after November 13th. Before that time, all required equations are posted in a separate document. Here you see two different ways of performing a collapse test on a tubular. In both cases, the internal pressure is zero and the test specimen is surrounded by a pressure chamber. In case A, the pipe is exposed to outside pressure between the pressure seals shown. There is zero axial stress. The maximum outside pressure that we can apply is called the nominal yield pressure under zero axial stress, and the parameter is denoted PA. According to the von Mises maximum distortional energy theory, yielding will start on the inside wall of a tubular when the outside pressure reaches PA. This is an example of the zero axial stress datum that is the basis of the triaxial ellipse that is commonly used in the oil industry. In case B, the pipe is capped at the ends during a collapse test. We note that the axial stress now is compression. The effective axial force, Fe, is zero. The maximum outside pressure that we can apply is called the nominal yield pressure under neutral axial stress, and the parameter is denoted Pn. At this pressure, yielding also starts at the inside pipe walls. This is an example of the neutral axial stress datum that is the basis of the triaxial circle discussed in the SPE paper. It is interesting to note that PA is about 87% of Pn. This means that the nominal collapse pressure used in the oil industry is low. As stated by Lubinsky in 1975, sometime during the evolutionary process of petroleum technology, the nominal yield pressure PA started to be considered without any published justifications as the experimentally determined collapse pressure. From a well engineering point of view, using the neutral axial stress datum for pressure and load design is sensible. This datum is already used during routine buckling calculations, so why not also use it for general tubular design? The SPE paper 188605 advocates the use of the neutral axial stress datum for all tubular design. In PET605, all yield calculations are performed using the circle. Numerically, the circle calculates the same answer as the ellipse, since both models are based on the same theory. Two reasons to use the circle instead of the ellipse are simplicity and agreement with the buckling datum. Example 1 with solution is shown here. Please pause the video for a while to read through the text. Afterwards, it is recommended that you solve this example on your own. The tubular of interest is the thickest of the standard API 7-inch N80 casing. The diameter to thickness ratio is 13.0 for this pipe, and this is a thick-walled pipe as described by the API yield collapse equation. The solution to this problem is to rearrange x squared plus y squared equals 1 and solve for the outside pressure PO. Equations for x and y are given in the paper. Note that you can choose coordinates for both the inside wall and the outside wall. Since there are no bending stresses involved, you choose the inside wall since this is where the maximum von Mises stresses will occur. We see from the handbook that the commonly used collapse resistance is the one calculated from the zero axial stress datum. Casing with the nominal wall thickness of 0.54 inches is used for the special 7-inch applications only. This is quite a heavy wall thickness. For common weights and grades of 7-inch casing, the collapse mode is that of the API plastic collapse, and not the API yield collapse as shown in the example.